All right, hello. We are going to take a peek at propositions and then some things related to sets and the basics of set theory. So the first thing we want to look at here is a proposition. A proposition is a statement that is either true or false. And you might not know whether or not it's true or false. Say, for example, if it's a statement like all integers can be expressed as the sum of three cubes. There we go. All integers can be expressed as the sum of three cubes. So that's making a claim. And we have the set of integers, all the negatives, 0, all the positives. We're saying any one of those can be expressed as the sum of three cubes. That's either true or false. Now, we may not know if it's true or false, but it is either true or false. And so this is indeed a proposition versus a statement like integers are better than decimals. Okay, this is certainly how many of the Germans, mathematicians early on would have believed that the decimals are the Menschenwerk, the work of men. But it's a subjective statement. I mean, there's some things the integers do really well. There's other things that they don't do very well. So to make this claim, it's not necessarily either true or false. It's not about knowing whether it's true or false like the first one. The first one was either true or false, even if we don't know the answer. It turns out that one is false because there's certain numbers that cannot be expressed as the sum of three cubes. But the claim is either true or false. Here, integers are better than decimals. It's ambiguous. We can't say that it's either true or false. So this is not a proposition. Let's see. What about all real numbers they just did away with this nice Google whitepad that I really liked. I'm not a big fan of this one. I maybe need to keep searching around. All real numbers greater than pi, 3.14. Okay, this is also not a proposition, sorry, because it's not a preposition either. It's not a proposition because it's not claiming anything. It's referring to a set of numbers, all the real numbers greater than pi. That is indeed a set of numbers, but it's not saying anything about those. If we'd say all real numbers greater than pi can be expressed in decimal form, sure, and that's actually true. Or all real numbers greater than pi are positive. That's also true. All real numbers greater than pi are divisible by 2. That's not correct. But all of those would be propositions because there's some kind of claim. It's talking about some set and then something about that set that's either true or false. So to be a proposition, you have to have a statement that either unambiguously has true or false value that can be assigned. Even if you don't necessarily know whether it's true or false, you know that the statement itself could be labeled as true or false if someone had perfect knowledge of the world, let's say. All right, so that's proposition. I think I'm actually going to make a separate video for the sets.